Okay, and then it's recording now, so I'm going to share the screen. Okay, so we are now recording. I will post these on YouTube. So the YouTube channel for the class, I'll provide the link if I haven't done so already. Okay, and then you can just get the discussion from there. All right, so as I was saying, we'll cover this review of NumPy, which is basically a very powerful tool. Then we'll start actually with a tool called Weka. This will allow us to do machine learning in a GUI interface. So this will be, it's the easiest way to do machine learning, basically. You don't have to write code. You just, use like Windows kind of point and click. And it's actually really nice. I like to start here because it's a nice way of just seeing the whole pipeline from beginning to end without it being, removing all the complexity, basically, and just focusing on, okay, I have a problem, I have some data, I need a model, I train it, evaluate the model. So we'll cover that. We can cover Weka in like one lecture, and that's how easy it is. And it's actually a really good tool for prototyping. I do recommend it whenever you have a problem, you should start there, start with that. But it's probably not enough to be able to build a really nice application. And so for that, we're going to use other tools that we're going to learn about in the class. Now, this is a foundations class, so there will be a focus on the algorithms themselves and understanding how things work from scratch. Okay, so I'll do a mix of that, understanding the algorithms from scratch, and then also showing you like the state of the art. All right, because coding something from scratch may not be the best way to attack a problem, given that you may insert little errors in there. So you want to take advantage of toolkits that are available. So in that case, I think last semester I used Keras, which is one of the easier ones, deep learning toolkits. This semester I'm thinking of just using PyTorch. So it just depends. I do believe it doesn't matter. All right, so I'll see which one we are going to use. Okay, so that's Weka. Then basically here we get into the algorithm. So the very first machine learning algorithm that you will learn about is KNN. It's called a k-nearest neighbor. So you will literally code that from scratch. All right, and it'll show you how it works, how things work. Then after that, as you might imagine, the hot topic today is deep learning. So we're going to get into neural networks. So we'll start with the perceptron, which is the very first concept of neural networks, leading up to deep learning. To be able to implement deep learning, we will need to be using one of these toolkits, like either Keras or PyTorch. Okay, so we'll learn how to do that. Okay, but the great thing about this is whether you do something in NumPy or you do it in TensorFlow or you do it in PyTorch, I don't want to say that they copy each other, but it's almost like they all copy each other. All right, so really the ideas are obviously they're all based on neural networks, which is just one idea. The algorithms also are just one idea. That's math, right? So you want to think of, there's only one math, and then either NumPy, which is JAX, or TensorFlow, or PyTorch, they all implemented that math into their frameworks. Okay, and there's a lot of things going on there. So we will, as I said, we will cover some of the state-of-the-art tools, which is what you would use to solve problems, but we will also try to understand the algorithms by coding them from scratch. Okay. So anyway, that's the very beginning, the first third of the class. We'll just cover a very basic algorithm, KNN, and understanding the whole machine learning pipeline. How do I take data, deal with data, what is training a model, and then how do you evaluate if I have a good model or not, okay? Now, one thing, because a lot of your cybersecurity students, I believe, of the major, we will have some cybersecurity related data sets. So I will use the classic data sets, but I do also have some like malware and intrusion detection, Internet of Things kinds of data sets. So it'll give you at least an insight into, okay, if I have these types of problems of network security or cybersecurity, how do I convert that into data that can be processed through machine learning models? Okay, so we'll cover that. I already loaded the data sets, so we have those available. Okay, yeah, so anyway, I don't want to go over all the topics because it gets into a lot of very detailed things. But you can see the sequence. Now I can tell you that Sci-Far 10 is likely either that one or MNIS will be the challenge, and probably Sci-Far 10, where will be this competition. All right, all of you are going to compete against each other, and we're going to have a leaderboard to see who gets the best performance. Okay, and wins basically like a trophy. All right, so the idea is that it's just for you to experience the actual way that you would do machine learning, right? So you have to compete against others, and you're gonna encounter certain things like some of you have GPU machines, and so your life will be a lot easier just because of it. Because yeah, go ahead.
Can I use Anvil for this course?
Anvil, is that a GPU?
It's like I think it has GPU.
Well, I mean, that's what matters.
It's in West Lafayette. So like I can ask the station.
Oh, okay. So you can help me with that actually. Do you still work there?
I don't work there, but I'm in the Slack chat.
You still have access to it?
I have access to it.
Because we have a Scholar, right? And there's the GPU queue thing. So we can probably get access to that. Yeah. So that's a good point. Remind me to request for that access. But I don't know about this Anvil, so you'll have to tell me. Okay.
It's like a new version.
Okay. If it's a new version of Scholar, then tell me about it. Yeah. All right, great. Yeah, so basically, as I was saying, machine learning, the problem is you have a lot of it, right? You guys have all heard about ChatGPT and you hear that it's such a great model. What you may not know is that it took millions of dollars to train it. It took 10,000 GPUs, and it took basically the equivalent of all the internet and all the books in the world to train it. That's a lot of data, right? That's a lot of, huh?
And it runs off of a data center too. So
I mean, I'll give you this piece of insight. Microsoft gave $10 billion to OpenAI, right, as an investment. But that money goes directly back to Microsoft in the form of what? The use of Azure, which is the cloud that Amazon has. So really, Amazon gets a good deal, right? So they give 10 billion as an investment, they own that, and then they end up using most of that money just for cloud. So really, the expenses of these big companies are really the salaries of the scientists that they have, or the GPU, or the processing power. So unfortunately, or fortunately, however you want to look at it, the state of AI today is that you need GPUs, you need supercomputers, basically, because you have really large data sets. Now, this is a fundamentals class, so a lot of the data sets that we're going to be using are big for us, like Sci-Far actually is going to be big for your CPU. Okay, so you might have to run it overnight, but it still runs on your CPU, on your good brand new laptop. If you have a GPU, obviously that's an advantage. Okay, so we'll talk about that later. But anyway, the class we're starting at the beginning, so the goal is to study the algorithms and demystify basically what machine learning is. Okay? By understanding the algorithms, big topics, like I said, one big third of the class is neural networks, and then another third of the class is just the very basic stuff in the beginning. Okay, and then in the end, I have a few like the things that are also part of machine learning and important, just not the main topics, like reinforcement learning. Anyway, so this is the list of topics, okay? So we'll get to that through the semester. Let's go to resources for the class, all right? So like I said, the environment that we need to install is Anaconda, so I'll talk a little bit about that in a sec. We'll use Brightspace. Basically, all the code in the class is on my GitHub, so you can just get it from there. I recommend actually that you go in already, just start looking at what's there available. You can always just retrieve it from there. Okay, I usually just explain how things work, but you can just get the file from there. A lot of machine learning, you'd be surprised, the hard part is not the algorithm itself. The hard part is the data. That's what the nightmare or the hard work of data science is. You have a problem, you have data, and then how do you go from that data to the format that will fit into these neural networks or this KNN or whatever the algorithm is. So a lot of your really important coding skills come in just doing that conversion, all right? Making the file ready to go into the algorithm. Because let's say, you know, there's a topic called the CNN, right? And that's a powerful neural network. Well, as it turns out, you can just, you build one CNN, you can use that for many problems, right? You can make little tweaks to it, but in general, it's always the same thing. So that tool is already created, and you can treat it as a black box that takes inputs and gives outputs, right? The problem is that input needs to be in a specific format. So if you have network data, or you have children's stories, right, from Potter, the Brothers Grimm or something, or you have audio or images, they're all different formats that need to be converted into the format that goes into machine learning algorithms. All right, so that's the idea. That's the hard part. But once we cover an algorithm, you pretty much understand it. You pretty much have the code already, and then you just learn how to make the changes that are relevant. Okay, so that's kind of how it works. So again, the hard part is the data, actually. Okay, usually if somebody invents a new algorithm, they start to abstract it and abstract it more and more until it's just a black box that takes inputs and outputs. And this is still in the code, right? So, but that nobody abstracts the data, not really. All right, so that one of the resources will be the GitHub. I think I have that here, actually. Yeah. All right, so you can find it here. That's the Machine Learning Foundations GitHub. So this is my GitHub. And then you can just click on Machine Learning Foundations, and all the files are going to be here. So I may add a new files. These are files from previous semesters, or modify them, but in general, pretty much everything is in, all right, all the scripts. Obviously, there's the YouTube channel. All right, I'm recording this video, or should be recording this video, so I will be posting that there. I also have this resource, which I used a lot during the pandemic, and I stopped using it, but I may actually bring it back. I'm still debating that, because it's got a calendar, so I can keep more like organized topics. So I'll try as best as I can to, I haven't updated it yet, but I will be updating it. Okay. Now, this website does have some important resources that I want to point out. Okay, so you can get the path there. Okay. And some important resources are the YouTube channel, which should be this. So you can find the YouTube videos there. Right, so it goes there. And then the GitHub is right there. Okay, which I just pointed out. And I have some, we need a lot of data sets, and they're scattered all over the place. So there's some files here that we might use, okay, and in various places. So a lot of this is getting data sets. We're going to get data sets from other universities. I have some data sets here, some data sets come from like the actual program that you install. So it's going to be very specific to the tasks that we're doing. So for the most part, I try to like accumulate the data sets. This is Scholar, actually, which is what Henry was talking about with Anvil. So in the past, we have used Scholar. So Scholar is like the Purdue cloud, if you want to call it that. So there is an option to get GPUs. So I haven't requested it yet, but in the past, I've been able to request it, and we can have access to it. Okay. So that will be, I'll discuss that if we get to it. And then the other programs that you might need, Weka, for instance, will be a tool that we will use at some point. So let me click on that one. Right, so there's Weka. Weka is like a GUI interface. Go ahead, if you have your own laptop, go ahead and download it and install it on your computer. Okay. We can install it on the machines, I believe, but it should be an easy install. Okay, and this is one of the first tools that we will use, not today, but in the future. Okay, so definitely try to install it. So this is an important one to have. However, the most important thing to have is Anaconda. Okay, so Anaconda, like I said, if you took 372 with me, you probably already know what it is. It's for creating multiple environments, right? And so the advantage of that is, I'll give you this example. Say that you have a program, right? And this program runs with PyTorch, no, it's Python. Let's use Python. You're all familiar with Python. So let's say you have a program and the libraries can only run on Python 3.9. But then you have another program that where the libraries or the program only runs with Python 3.7. So what do? So basically in that situation, you would have to upgrade, right, your 3.7 to 3.9, and then you get your program to work. But then what happens to the programs that need 3.7? Now they break. They don't work. You see that? So Anaconda is an environment manager. So it basically allows you to create multiple environments. So now you can have an environment for Python 3.7 and an environment for Python 3.9. Do you see that? That's really nice. Okay. And then we just also will just use pip. And so basically you create an environment, you use pip, and you install all the libraries that you want with specific versions, and you can create however many environments you want. And so this is something that we will be using this semester. So at some point I will demo all of this, of course. I'll create a new environment for the class, install the libraries. The only thing that I ask you to do now is to install Anaconda. Now, Anaconda should be installed on these machines already. That's one of the things I requested. And we can install software to it. The only problem, I believe, is that if you turn off the computer the next day, it may not be there. But that's not a problem because it's usually really quick installations. A pip install is usually really quick. Got it? Does that make sense? All right, so again, to summarize, two programs that you need to install are Anaconda and Weka, okay? We're not gonna use them today, but you definitely should start looking at them. I can click on Anaconda just to give you an idea. It's not the only environment manager, but it's definitely one of the most used. Everything you need to get started in data science on your workstation. Okay, you can see that. You know, basically you have access to all the libraries. Jupyter Notebooks. So I'm sure you've used Jupyter Notebooks before. We'll be using Jupyter Notebooks for pretty much everything, and that should be pretty nice for seeing the outputs for your homework. I'll say this now, please don't submit the Jupyter Notebooks. Instead, you can generate a report, like a PDF or print it to PDF or something like that, and then you will submit them. But it's got all the things that we might want to use, like PyTorch. This is, when you say PyTorch, you're saying the state of the art of machine learning and deep learning. Or when you say TensorFlow, you say Keras, NumPy, Pandas, Matplotlib. These are all the libraries that we're going to be using throughout the semester. And believe me, we'll start with very basic stuff and very simple things, you know, NumPy and creating a variable, and you're just going to, you know, build up your skill set. Okay. I do recommend, you know, create your own GitHub, load your own scripts there, start organizing them. And it's like a cheat sheet, right? You can always go back to it and reuse code. All right, anyway, so this is an easy install. It's, you know, you download it, it's like a Windows installation, and that's basically it. The operating system, as I said, you can definitely use Windows. There's no need for like Linux or Mac, no VMs. Don't even think of going that route. All right, stick with your Windows operating system instead of doing something like that. I use Windows here. I have usually like to use my Mac, but I'll be doing everything in Windows. Okay. I already installed Anaconda, so we'll see later if but I want to get through the administrative things first. All right. So anyway, these are the resources. So like I said, the Anaconda, Weka. Oh, the GitHub and the YouTube channel. So those 4 links are really important. Okay, you know, so you'll want to remember them. All right, so I've talked about these 2 things. So we can go back to the course on Brightspace. and take a look at the syllabus. And then after that, I will just give you some demos of little projects that we've done in the past, kind of give you an idea of what you could do. So the basic, there's a pipeline. You'll hear me say this a lot, the basic pipeline, right? And what that means, oh yeah,
Yeah, I was about to say what's that.
what does that mean? What does a pipeline mean? It means going from, you have a problem, right? And that problem is basically some data, right? And you want to do something with that data, like predict. So for instance, you have images of cats and dogs, right? So then you want to build a model that you give it a picture and it tells you, oh, that's a cat or that's a dog. That's a problem. So when I say the pipeline, I mean, okay, I need a model to do that. That's at the end of the pipeline. But at the beginning of the pipeline, I need some data. The data is going to go in through this pipeline, get processed, then process again, then process again, then it goes into the machine learning algorithm. We're going to train, then the model's trained. Now we have evaluation data, goes into the model, and then we're going to get some performance metrics so that we can say, my model is actually good or bad at this problem. So the pipeline is just a sequence of steps. And you can actually see it in the, I have a drawing of what I mean by, this is the machine learning pipeline drawing that I have. It's something I was going to discuss later, but basically you can see, you identify the problem. And that's actually what we're doing. Right? Word problems, how do we even begin, right? And so we're going to look at some cybersecurity problems and also some cats and dogs problems, you know, classic examples, as well as, you know, cyber examples. And yeah, identify the problem. Then what do? You collect data. So a lot of the time for some of these problems, we have data already, right? That's what I was saying about data sets. There's a ton of data sets. Then we do feature engineering, which it includes several things. Then we do pre-processing, which can be labels, one-hot encoding, cleaning, transformations. Then we have scaling. You can see that there, which is this. Then we have feature ranking. Then we have the data set basically ready. So look at all the steps that we have to take just for the data set to be ready. And then this circle here represents the machine learning algorithm, or usually what's referred to as the model. You guys understand? So as I said, although we're learning, maybe there might be like 40 main algorithms. We're not going to learn all of them, but we're going to learn some of them, and definitely some of the most important ones, okay, that you can use. But you can just reuse these algorithms. You just have to know how to change them, but processing the data takes a bit, okay? And then once you do that, you have the problem that you're solving, and then performance evaluation. Always performance evaluation. So we're going to learn how do we evaluate so we can make the argument that we have a good model, okay? All right. Any questions so far? Nope. All right. Yeah, so that's what I mean by the pipeline, all the steps, okay? All right, so let's start with the syllabus. As I said, just real quick, formally give you some of the details. All right, so this is ITS 365, I'm Professor Calix. I'm in Anderson 241, and my office hours will be Tuesdays and Thursdays, 2 to 4. So before my 4 o'clock class. The course description. So this course provides a basic introduction to the machine learning pipeline and related concepts. Okay, so topics covered include machine learning uses and applications, data set requirements, data pre-processing, data annotation, which is when you collect your own data, and validation, data representation formats, feature and feature representation and extraction, something called the vector space model, which is something very interesting that you're going to learn about, I'm sure. Then traditional machine learning algorithms. And then, so when I say traditional machine learning algorithms, I basically just mean everything before deep learning. Okay, that's basically what I mean. So everything before like 2012 is traditional machine learning. And then all the modern things really started in that period from 2007 to 2012. and evolve. So really, it's been only like 10 years, right? That we've had the deep learning as it is today. Okay, so traditional machine learning algorithms, we will cover some of them, not all of them. Machine learning algorithms and programming. So remember, a strong emphasis on understanding the algorithms themselves. Machine learning evaluation methods, which is the performance that I was talking about. Introduction to deep learning, which, as I said, we'll use PyTorch or Keras for this. And then some concepts like big data, when that's the GPU problem. So, what do you do with that? Oh, yeah.
Is Keras like an abstraction of digital?
Yeah, it is exactly that. So you have in these coding schemes what is like low level and high level. And basically it's like you have code, right? That's very core, and then you wrap more code around it, and then wrap more code around it. You keep wrapping to the point where it's very easy, right? Because now it's like a constructor or something that handles inputs and outputs. So it's kind of that idea. It's very object oriented. I should say that a lot of the schemes are becoming very object oriented, and that just makes your life easier. So Keras is like taking that to the very top. Is one of the most high level APIs. It's very abstract, but it's still coding. You still have a lot of flexibility. Actually, it's a good framework, and the reason that's why I kind of want to cover Keras a little bit and also PyTorch so that you have seen both. Yeah, go ahead.
I don't have a bunch of students.
No, this is what this class teaches.
There we go.
Yeah. So we'll cover these concepts, okay? We're not gonna get into the advanced. I can tell you this right now. We're not gonna get into the advanced deep learning algorithms. So there's machine learning, like traditional. Then there's deep learning until a basic deep learning algorithm. And then there's all the advanced deep learning algorithms. Okay, so we won't cover the advanced deep learning algorithms. We have grad level classes for that if you're interested, but you will definitely be able to create a model that is based on deep learning. So it'll be a deep neural network. It just won't be a transformer or, something more advanced. Okay, those are really advanced. Any other questions? All right, so I was going over the description. So introduction to deep learning algorithms, as I said, so basically a basic deep learning algorithm. Big data issues, so the issue of GPUs and all of that. Reinforcement learning, I will cover that. That's a fun topic for games, like having an AI play a game. So it's a fun one. Unsupervised learning, this just has to do with what if you don't have labels in your data? Like you have nothing to learn except there's data there. What do you do? So there are some techniques for that. There's supervised and unsupervised and semi-supervised. There's issues with statistics, like to determine if a model, the difference between two models is statistically significant. And then some special topics, which in this case would be the idea of something called transfer learning. And transfer learning just means, let's say Henry creates a really nice model, right? You've spent $1 million, Anvil, you have the resources to build it. Now others may want to use your model. They could take your model and then just keep it, but modify it a little bit for their task. That's called transfer learning. And so we'll cover a little bit of that, where we can bring in something that's really powerful and use it in our own thing and compare it to what we build and see the difference. Yeah, go ahead.
Here's the question: for what is the model? What is just like a list of like?
It's numbers, yeah. It depends on the model that you're talking about. If it's a neural network, I have this analogy for neural networks. Let me see if it works. It hasn't worked for other people, so let's see if it works. A neural network, imagine it's like this. You have a really big one, right? Like a ChatGPT. Imagine that you're going from here to that door, okay? But in between that, you have 1 trillion cities. Disorganized. It's like a map, right? There's 1 trillion cities. And there's more than 1 trillion roads to get to these cities. Do you see that? You want to get to an output over there, a specific output. but you don't know what's the most efficient way of going from here to that output. During training, you give it a lot of data, which basically means you give it inputs and outputs. And it's going to start to optimize and try to learn to figure out what are called weights, which is a nice way of saying, should I take this road or this road?
Which like bias.
Weights are values. Yeah, go ahead.
It's not kind of the same thing as Q value, or
It's not a Q. Q value in machine learning, you mean? Well, there's a Q learning, so it's an algorithm. But the analogy that I'm giving you with neural networks is, maybe it works, that imagine you got data here, and you want to get some data over there, specific pattern that you give it here, and you want to get a specific pattern over there, whatever it is, a binary pattern. If you will. But to get that pattern, given this pattern, initially you have randomness, right? And so you can think of it as a trillion cities connected by a trillion roads. So you could, how do you efficiently, given this pattern here, arrive at that pattern over there? So you have to know which directions to take in the network. Do you see that? And those directions are basically like saying, I choose this road to this city, and then this road to that city. But I can also take this road to this city, and then from that city to the other city, this road. And you're not just going on one road. You're basically like you have 6 cars, and each one is taking a road, and in the end, they all arrive together at the right pattern. Do you see that? But you have to learn that map.
and those weights are what the model can take.
Yes, the
Okay.
weights are lit. So that's a good question, right? So what is a neural network? 2 files. This city of random cities, but you have a fixed set, like that city is always there and that city is always there. You set the architecture and you set all these roads. You just don't know which roads to take. That's what the weights tell you, and that's usually a file. So you have one file that's the architecture, one file that's the weights. That's it. So that's why, let's say that I have this problem, right? Pattern here, and I want that pattern. So Henry trains the model. All that Henry needs to do is he's going to tell me where the cities are and the roads. That's the architecture. I take that. I can easily do that. You just tell me that. The hard part that you didn't know that required training is you didn't know which cities to take, like which ways say, okay, this road is more important than that. And that's a separate file that you can share with me. And then I can load that for my own city map and road map. And that's how it's done. Yeah.
Another very stupid question.
Yeah.
Like, do any of the classical search algorithms play a role?
Do any of the classical, so you mean like depth first search,
A-star search? Yeah.
A star? Where does A star come from here? Did you learn that in the AI class?
Like,
Is that what one of the ones?
I think so.
Okay, good.
It was
Yeah.
like A-star.
A-star,
maybe-
depth first search. So those are usually like tree search algorithms. So they're more like classical AI. However, that's not used necessarily in neural networks today, but it doesn't mean that you can't use it on top of it. But most of the neural networks we'll use are like graphs. I guess that's what you're getting at.
Yeah.
But we're not using a specific search algorithm. Instead, it's not smart. It's just like, this is why it takes a GPU and trillions of petabytes of data, because you really just run, okay, give it an input and an output, see what happens. Give it another input and an output, see what happens. Eventually, you start to get a good result, right? And that means that the weights are becoming better and better and better. But it's like a brute force kind of thing, where you're just giving it as much data as you can. You give an input, you get an output, and then you're evaluating the performance. Does that make sense?
Yeah.
Yeah, we'll get, those are a lot of concepts to discuss in 10 minutes.
So as
So
you can tell, I don't know much about AI.
yeah, so we'll get to that, but they're definitely good questions, okay? But the problem is not a problem of, like you said, like search trees. Is more of a problem of optimization, basically. And you try some weights, right? And you measure the performance. Then try another set of weights and measure the performance. Try another. Eventually, if you do that 1,000 times, I can tell you one of those performances will be good compared to the other ones, right? The problem is you can't just do that randomly. That's impossible, right? Instead, you have to have smart ways of making these updates to the weight system. And that's kind of the whole concept of neural networks, okay? So we'll get into that later on. Any other questions? All right. So as I was saying, some of the special topics will be this idea of transfer learning, which is the example I was giving you, which happens a lot today. Somebody trains a model and then others want to use it and just modify it a little, right? So we'll talk about that, but it's basically this idea of the weights, the architecture and the weights, okay? So these are the topics, which I'm pretty sure I mentioned them already. The prereqs for this class, basically, you've all taken up to data structures at this point, so you should have some good programming background. You've taken 265, hopefully, which should have given you the NumPy background, and you've taken your stats class, or you're taking it right now. And that's not so important, but that's also part of it, okay? There's no required books. However, that's a good one, Python Machine Learning by Sebastian Rashka and co-author. But you don't have to get it. All the code is provided on GitHub, and I'll provide all the explanations. However, if you want to read something, that's a good one. The other one is for Weka. I mean, I don't recommend getting it. All right, so the grading. As you can see, there's assignments here, and most of it is assignments, 50% of your grade. There will be 3 exams, 10% each, and then a term project. In this class, there's a bit of an emphasis on the project, so this one is worth 20% of your grade. I'd like to see good projects, okay? Which is one of the things I'll show you in a sec of some of the projects that you can do, okay? All right, please read through all of this. These are the things that the university requires me to add to the syllabus. The only important thing here is, for me, or I mean, it's all important, but the main thing that I want to emphasize is homework submission, okay? So usually we'll be using Jupyter Notebooks. Please create a report of that. You can generate a PDF, or you can print a PDF and provide your report. I will need to see that the code ran, that you did try hard to get things to work. So I need to see metrics, this whole pipeline. There will be like this pipeline that I expect to see in these assignments. Please don't email me assignments, okay? I won't accept emailed assignments. The only proper place to submit is on Brightspace, okay? And then this is just a list of topics. So yeah, so that's the syllabus. Hopefully that makes sense, okay? So the next thing I want to cover is, so I've had a lot of good questions, but don't worry if you didn't understand some of these ideas. I mean, we really have to spend time and do examples, especially neural networks. It's not such a simple thing to grasp immediately. I do want to show some projects, okay? So these are some ideas of projects that students have done in the past. Yeah, so I have this TensorFlow JS. The JS, as you might imagine, is JavaScript. So it doesn't mean that you code your algorithm in JavaScript, although you could. I don't recommend doing that, honestly, but you could, I guess. But the JavaScript is more for like the web development of deploying your website. So we have, in the past, I've done TensorFlow JS. It's basically a way of deploying your model to a website, or I've done PyTorch deployment, which is with something called Onyx. And then we have a third option, which is something called PyScript. I don't know if you guys have heard of PyScript, but PyScript is basically Python JavaScript, I guess, something like that. It's more of a recent thing, like I think it's about 2 years old. The idea, oh yeah.
We use Haskell.
I would recommend you stick with the tools that we're discussing. So as I was saying, so PyScript is basically a way of writing Python directly in like your HTML website. It's the same idea as in JavaScript, right? You can do in JavaScript, you put your JavaScript tags and you add your JavaScript. So now you can put PyScript tags and you can write NumPy, for instance, which is, if we can write NumPy in there, we can develop, because actually a lot of the algorithms we'll be developing this semester will be in NumPy, right? So you can basically build that way, or we can build it through something like PyTorch, where we train on a Jupyter, right, in Anaconda, and then when the model is trained, we export it. So now we have a file that we can just put on our website, and then we have, PyTorch JavaScript code that will be able to use it basically. And then we can have a nice little website for our application. Does that make sense? So some ideas that we've done in the, or some projects that students have done in the past. I don't know if the TensorFlow.js is here. It might be this one. I actually did not test this one. Yeah, so there it is. So what is this one? I think it was an even, uneven predictor, I want to say. Oh, there it is. So it's telling me that it's an odd number, right? Is it correct? It is, right? So anyway, that's a very simple one. I built, this is was done with Keras. So we, train a model, give it a number. It's going to tell us if it's even or uneven. So you can build a website for that. All right, this is a very simple one. We'll probably do something like this later in the semester. And the thing is, you guys know everything about web development, right? So you know everything about JavaScript. You're experts at that. And so you even know about databases. So you can have like SQLite in there, and that gives you further functionality. And then now you already know that. So then I just have to show you how to export the file and then interact with it, and you're able to develop your application. You can also deploy it to GitHub, right? So GitHub allows us to host simple static websites. So all you have to do, I do recommend that you do this maybe even today if you haven't done so already. Create your GitHub account, all right? And then you can deploy there, your HTML, CSS, and JavaScript, and your model can run. This is running on GitHub. So all I do is I put the files there. Okay. So that's a project. I have a few other projects here. Deploy to web. These are examples of either PyScript or Onyx. Okay. So Onyx, as I said, is Onyx. So when the example for TensorFlow.js, actually you were locked in to TensorFlow because it's a specific thing for that. But Onyx is from Microsoft, and it's actually meant to be more general. So it should support TensorFlow, PyTorch, JAX, everything basically. Okay, so that's a nice one. And then, as I said, PyScript just allows you to code everything from scratch, for those of you that may want to do that. So I think I have an example here of this one. Classify image. These are some students in the past. They created an application that it just would tell you if it was a panda or not a panda. Don't ask me why, but that's what they decided to do. Okay, I forgot to include an image, but you would click on browse, right, and select an image. And this actually, they wrote the functionality really nicely so that it can take an image of any size and resize it to the proper size. And then basically the model would predict if it gives you like a true or false. Is a panda not a panda? All this code is available here, so you guys can use this for your own reference, okay, when you develop your project, okay? And you can play with this at home, okay? And unfortunately, or if you have an image right there in your desktop, go ahead and do it. I don't have an image for it. Now, don't expect these models to be perfect, okay? Don't be so critical because it takes a lot of work to get a model to actually be perfect. So usually, we want to achieve 80% accuracy or precision or F-metric. You know what I mean? So we'll learn about all these concepts later. So their model worked okay sometimes, and sometimes it would see a tree and it thought it was a panda. It just It's kind of like that. So you have to like measure performance statistically. Like, what is my error rate, basically? I have a 10% error rate or something. Henry.
So if the prediction rate is 0, that also works.
No, because,
You just have to, like,
well, actually, let me tell you this. If you have 0, you have a really bad model. Because I could build a model that just flips a coin. And 50% of the time, it gets things right.
That's what I'm saying is that, like, if you say you have a model that's at 0% accuracy.
It's really bad.
Right?
It's really bad.
Well, you will just like return, return false.
If you have a 2-class problem, panda, not a panda, it should be at least 50% accurate. Right? But you could just,
Here's what I'm saying is that, like, in case it's a binary, it's 100% not accurate. You just have to.
yeah, this is what I'm saying. It should be greater than 50%. You at least should have 50%. Otherwise, because you could build that just by a mechanical flipping of a coin. Eventually, it would get things right, statistically speaking. Okay? Yeah. But it's a good question.
I'll
Yeah.
have my point algorithm.
Sorry?
I'll have my point algorithm.
A coin flipping algorithm. I want to see that actually. Okay, another example, wine quality. These are regression. They can be classification too. So you can do things like this. Some students in the past, actually, for some reason, last semester, everyone ended up doing a sports themed project. So they want to know who was going to win the hockey league or who was going to win. Some of them were athletes, so they wanted to know like tennis or basketball or something. Yeah, basketball. But yeah, so they would enter metrics and then it would give up predictions. So this one should say wine quality. Yeah, so it does something like that. So I think I have default values in there. They're not actually. So this, if you want to think of this problem, we'll do this in class and we'll do it right. But the idea is basically you have a wine type. And you'd have acidity, you'd have like pH balance, alcohol content, all those things, right? So you would enter those parameters. And then when you hit run, it would give you a rating for the wine quality, which is from 1 to 10, I think. So it should be like, if it's an 8, it's a good one. If it's a 3, it's a bad one.
It's a negative 33K.
Right. And as I said, there is no value of wine quality that is 87,608. I don't have the right values. You have to change it. But you can come back to this later in the semester or just find the right values. It'll work. It should. Yes, please.
Are most of your students using Python, would you say, or like Jupyter Notebook, or are they using other?
Yeah, so one of the things that you'll see in the class is I use Anaconda and Jupyter Notebooks and Python. So that's going to be pretty much your environment. I will demo that starting on Thursday, possibly, or if not next week. Okay. As I said at the beginning of class, if you have your laptop, the 2 things I want you to install are Weka and Anaconda, and I showed you the link for that. Once you download Anaconda and you have it on your computer, I'll show you how to create the environment, do the pip installs, and then we'll install Jupyter, and then we'll always pretty much launch a Jupyter notebook, and we'll do it. But yeah, for the most part, that will be the environment. So Windows, Anaconda, Python 3.7 to be precise, and then the libraries that we need. Okay, all right, so this is another, as I said, project. Oh, this one's a nice one. This won't work for me because I think I have my camera on. And this is supposed to be how to use a camera. So one of the students wanted to do sign language. So sign language, you do like, you sign, and then it gives you what that means. So that's what they were trying to do. So basically, if you guys have these open, you can go ahead and try it. You press on start webcam. So obviously this is just functionality of the website, the libraries. Mine probably, I don't think it's gonna work. Because I'm using the camera. Yeah, so I don't think it'll work because of that. I'm already using the camera, but if you run it, it should start the camera. And then if you do something on it, it'll give you a class that's predicting. It's also not very precise, but it is getting at the task. So try it out. You guys try it out on your computer. All right. Now, we don't always need neural networks. All right. So that's one of the things that we will learn in the class, that sometimes there's a tool called XGBoost, for instance, that is really good. And it can beat neural networks in some small scenarios. So I like to show this because it helps us to understand when it is actually more appropriate to use deep learning. Yeah.
What is X?
It's just one technique. It's a tree, actually. It's if you remember your DFS and all that, the tree searches. So it's based on trees. It's an algorithm that builds trees to make decisions. But XGBoost is like taking that to it. It's like the state of the art. Okay, but it's a tree-based technique, not a neural network. And so, but the point is, this actually solves our tasks really nicely sometimes. And so we'll learn other things beyond deep learning. Okay, and you can deploy them as well. So this is also deployed. Yeah, there's the value. Oh, 3.42. So this one, learn an average or something.
What's better than negative?
Yeah. What else? This is the classic iris. Oh, yeah, sorry, I didn't intro. This is a different approach. So the previous ones that I've shown are either TensorFlow or they are PyTorch. This is PyScript. And so this is basically you writing the code from scratch in the website itself. So KNN is an algorithm that can, in 10 lines of code, can be written in NumPy. So that's an example of this. It's taking a while, actually. But I tested this earlier and it was working. Basically, it's the same thing. It should load the PyScript, and it's basically running NumPy, but on the website. Oh, there it is. Okay. Yeah, it just takes a little bit. And it may just be my implementation is not the best. Okay. So you can see here kind of the same idea. You have few inputs, right? The values, and then you click generate, and there's the output at the bottom. So it predicted 0. So that I've given all these scenarios, right? So sometimes it predicts 0, sometimes it's 1. So you can test the quality of the model, because if you select this row, these values, then it should give you a 0. If you select these rows, right? And so that's the idea. So we'll do this example. This is the classic iris data set. So it's one of the very first data sets that we will look at. Okay. Very easy, and it allows us to understand things in a very simple way. And then the last one that I'll show is also written in PyScript. And this is a type of a generative model. It's a poor person's generative model. So if you've ever heard of Stable Diffusion, have you guys played with that at all? So it's a tool that allows you to write like the pig wearing an astronaut suit on the moon, and it's like.
Is that where it fills in the gaps? Like there's like 0 pixels there.
It just draws, so it like creates images just by your description. So if you've never played with this, you should try it out. It's called Stable Diffusion. It's like almost like ChatGPT, but for images, and it creates these amazing images. So this is a very cheap generative model. So what this does is you give it these inputs, right? So we have 2, 4, 6, 8, 10 inputs. And then when you click generate, it generates an image, right? And then this is basically, imagine this is like a furnace. So it's showing you what a furnace would look like. So those are things related to, what does a furnace take? It takes like coal, and it takes like natural gas, oxygen. So if you throw more of that, it gets hotter, right? And if you take less of that, it gets cooler. So that's what this is supposed to show. I don't actually have like the values, but I just like change them. Look at 0 there. All right, and I generated an image below. And are they similar or slightly different? This one has like more of these little lines here, right? And this one doesn't. And the changes here are subtle, right? Because this is a furnace. It's not really it models an actual furnace, so it's not gonna be such a huge change. But you could do this for other things, right? So you could, I've always thought that a nice project of this would be like, start with a person and make them more cat. Or make them more bird, you know what I mean? Like mix it up a little bit. So at the end of the day, it's just an averaging thing that's happening in the back. So we'll definitely discuss this technique. Should be a fun one. And it's super easy. And this is implemented like on the website related to CAN, right? So this is not a neural. Anyway, I just wanted to give you this idea of the projects that you can do. As you can see, very basic stuff. And we're just gonna, learn how to train these models. Any questions? Any questions? Right, so you play with those if you want. You should be able to find them on the GitHub. All right, so I think that concludes kind of just the introduction of the class, right? Telling you what this class is about. We've gone over the topics, you know where all materials are and how to submit. So now we're gonna like formally start the class, the first like lecture topics. So I'm going to go to Brightspace for that. And as you can see, it's really these two things here, right? So we're going to be spending this week and next week just on these two things. So as I said, hopefully in 265, you spent a good amount of time on NumPy. We've done a few of those vector multiplications and things like that. So I have like, I think like 50 problems or something like that. And I may even give you more. So my view on this is the more you do of these, the better it is. Now, for this homework, you could easily just copy paste, right? You can copy paste, watch your favorite movie, talk to your friends, copy paste and submit it. I won't know the difference, but what I want you to do is really to sit down, code it up, concentrate on what you're doing, and you'll get something out of it. All right, and it's basically consider it background so that everything else that we do in this semester is easier. Okay, and again, as I said, it's about muscle memory. I will do some examples and I'll cover this, but at some point I'll just give you a whole bunch of problems to do. Okay. And so I recommend that you type it up and try to get it to work. Okay, and to try to like familiarize yourself with it. All right, so that's this idea of matrices, vectors, and NumPy. So NumPy examples, and then as you can see, I will give you later a set of 3 to 5 problems, which I expect you to solve with your skills in NumPy. But before we do that, this week, except maybe to show you the environment on Thursday, we're not going to do any coding of any kind. Instead, we're going to look at problems. Like, think of it as you have word problems, and what do you do with them? Where you have somebody says, build me a machine learning model for my cybersecurity problem. How do you even begin, right? So that's kind of what we're going to do. So that's going to be here. And we're going to cover the machine learning pipeline, which is that drawing that kind of somebody asked about. And then I have these files called ML problem definition. Okay. So let me just, because I have this in here, let me open that file. So someone had asked this question, so I kind of jumped the gun there. But basically, everything that you'll hear me talk about is always like, what's the pipeline? Build a pipeline, the ML pipeline, right? And it's just like inputs and outputs. That's literally what it is. And so you can think of it as a black box. You give it an input, you get an output. You saw in the websites that we just looked at for previous projects, right? There's some pipeline there, but really all you had was text boxes. So that was the input, press the button, and then you would get some value or it would generate an image. That's the output. You see that? Okay. So that's basically the machine learning pipeline. As I discuss it, these are a lot of topics that we have to spend some time on. But basically, we start at identifying what it is that we're trying to do. Maybe you're really interested in social media, or maybe you're really interested in malware analysis, or maybe you're really interested in text understanding, a spam, for instance, right? So is this email spam or is this email not spam? All of those are very different problems. All of them, I guarantee you, can be modeled in some way through machine learning. The key is you have to know how to go from that and then data to how do you feed it into your algorithm. So in between, we have all these steps that we can use, such as collecting the data or having a data set. So we can collect the data from social media, web crawlers, scraping data, downloading images, right? These are a lot of mediums, and usually a lot of examples that you see are images, right? And images are nice actually in machine learning because they're intuitive. We understand images in a specific way. But not everything is images. There's text. There's also what is called tabular data. And an example of that is like that wine quality, where you had some metrics to predict the quality of the wine. But we have other things, like we have the cybersecurity data sets. Well, actually, you'll have malware, right? Literally like malware. Or you'll have network data, packets, right? So that's, for an intrusion detection system, something like that. All right, so then after you have your data, you have to represent the data. So usually a nice technique for that is called the vector space model, all right, which is this. So we'll learn that. It's like in geometry when you learn about Cartesian planes and those kinds of things. Yeah.
Is that also calculated?
I mean, this is just geometry from high school. You all covered this in high school. All right, this is just, you did this, I'm pretty sure. All right, this is just geometry. And so you'll learn that. We'll talk about the vector space model, but it's a technique for representing the data. So you always want to think, how do I make this into the vector space? Okay. All right, I'm always also, if you notice, I wrote this orange arrow here. For every word problem I give you, I will always pretty much just say, give me the X and the Y. If you're able to create that X and that Y, which means giving me the right dimensions and the little details about that, you've converted your data into the input to your machine learning models. So there's always going to be that approach of what is X, what is Y. And that's what we'll do this week. Like today and Thursday, I have like 5 or 10 problems. We'll think about it, and then I'll by hand solve it. And hopefully you guys will learn the approach. After that, you converted the data to the vector space model. So it's technically ready to go into machine learning algorithms, but you should still do something to it. Just to like improve the chances that your algorithm will do well. So that's usually like something called one-hot encoding, transformations. Then you have something called scaling, which if you notice here, I wrote important. Machine learning likes numbers. All the numbers. Remember that map of roads and cities? All those numbers in there, machine learning wants really all of them to be between -1 and 1. So even let's say that one of those neurons is predicting like a 365. Well, you want to scale that to somewhere between -1 and 1. It's just a thing of how it works. Yeah.
So like say like for images like RGB values.
Okay, the 0 by 255, you scale them to 0 by 1. That's what I mean. Exactly that. Okay. That's a good point. Exactly that. That's what I mean. Or it could be from -1 to 1. You can do the scaling however you want, but really, especially also you don't want values to be in really weird scales, right? Like that you wouldn't want, for instance, you have age from 0 to 100, height is from 0 to 6. So one goes from 0 to 100, the other one goes from 0 to 6, right? The scales are very strange, right? Like one is really big, one is very small. Instead, if you scale them, now they all go from 0 to 100, and it's just proportional. So machine learning likes that, for instance, okay? So it's one of the things that we will be doing, okay?
It's like,
yep.
And like you want like, and your goal is to make it all uniform.
Is what?
Is your goal to make it uniform for scaling?
Not uniform distribution, but we want to make it so they're all on the same scale. that you decide beforehand, like from 0 to 1 or from -1 to 1.
And like say like the height thing, we just check like say height would be like say we have the maps something. And you just-
Then it would be a 1, yeah. So if it's 6 and it's the max, then it's a 1. If it's like 3, which is in the middle, then it'll be 0.5. It's proportional, but it's scaled. All I'm saying is machine learning likes that. And you guys will see it. Like when you start doing things, it won't work, and then you just scale it, and now it's better. It's just particular little tricks that you have to be aware of. You use those a lot, like everywhere. All right. There's other techniques like feature ranking and dimensionality reduction. I will cover this when we cover the WECA, like in 3 weeks. We'll cover that. And then finally, the data set ready for machine learning. If you notice, that's going to be your X and Y. So when I give you these word problems, I'm always looking for X and Y. Okay, the sizes and everything. X is going to be a matrix, and Y is usually going to be a vector. Okay, so it means that one is a column, whereas the matrix is rows and columns, and the data is represented there. The algorithms, we have several algorithms. I like KNN a lot, and so I play with KNN a lot, and so we'll cover it in the class. It's easy. You'll code it from scratch in NumPy. You know, it should be fun. Actually, KNN is what was used to generate those images, so it's actually quite possible. Yeah.
But what's naive?
It's a base that's naive. Naive just means it makes some assumptions that no longer make it true base, but it still works.
Okay.
We'll cover naive base. So naive base is in WECA. It is one of the traditional machine learning algorithms. It is by almost definition, usually the fastest of all machine learning algorithms, but it also has the worst performance. So then you might say, why is that good to use? Well, it's good because it gives you a base. Like, you know, your model can be better than naive base. And if you can get the score for like if naive base gives you 98 performance, you don't need to do anything else. You're done, right? So you got a model that works and it's super fast.
You can't really get better than that.
You can't get worse.
So you can get worse.
Yeah, that naive base. Yeah, it's a probabilistic technique. It's based on naive base, which is probabilities. But we'll cover. It's very easy to implement. So it's one of the techniques that you should know as part of foundations, although it's not one of the most powerful ones. KNN, on the other hand, can be very useful. Then, as you can see here, I have perceptron, neural nets, DNN. So that's all neural networks and deep learning. So we'll spend about a third of the class, the second third, just on that. Okay, so we'll go from perceptron, the simplest, to a multi-layer perceptron, which is basically a neural network with one hidden layer, and then deep learning, which is just more than one hidden layer. So we'll discuss all of that. You know, what makes them so powerful, you know, some of those intuitions. And we can code this up to MLP and NumPy. After that, we'll be using one of the libraries like PyTorch or Keras. Okay. This includes also optimization concepts. We'll look at something called logistic regression and linear regression, which I believe all of you have covered linear regression already in your stats class, right? So if you took your stats class, I'm sure they covered linear regression. So you have some sense of those concepts. So we start with linear regression here, which should be intuitive and familiar. Yeah.
Last took stats class was 4 years ago.
Okay.
Yeah.
You can just, you know, a refresher or something, Wikipedia. We'll cover it in class, and it should be pretty straightforward. But neural networks make sense to understand them like that. You start at linear regression and you build up, because really what it is this linear regression, and you add a little bit, and then you add more, and then you keep adding and adding, and eventually you have a deep neural network. But the ideas are very similar. You're building on top of previous things. So it's very sequential. Okay, so those are some of the algorithms. There's other ones like k-means, hidden Markov models. Somebody said Q-learning. So there's lots of algorithms. We won't cover all of them, okay? As time permits, I'll cover, but definitely neural nets I'll cover, since that's usually the most important one. We'll cover two types of problem, which are the classification and the regression problems. And what that means is regression is when you're trying to predict, let's say the housing prices. So I want to say, given the square footage, what's the price of this house? So you would literally tell me, oh, this house costs $235,560. You give me that number. That's a regression type of a problem, right? A classification problem is one where you say, I want you to tell me for this house, given the square footage, should I buy or should I not buy? You see that? So it's just, that's a class. It just predicts a 0 or a 1. Or it could be multi-class, like buy, don't buy, wait until next year, for instance. Just 3 options, 3 classes. So we can model problems like that are called classification problems, or we can model problems that predict what is called a real valued number, which can be any number that we want. So a good example actually is temperature, or Fahrenheit to Celsius. We know that there's an equation, right? We learned this at some point in school. If I want to know what's the equivalent Celsius, I just need an equation, put in the Fahrenheit temperature, I get the Celsius. It's 32 degrees, so that's what in Celsius? 0. And if I get 100 in Fahrenheit, that's 212 or something like that.
I have no idea.
You guys don't know. Okay, but anyway, there's some interesting things there, right? So we can basically, given a value, get another value. Okay, so freezing is 0, right? In Celsius, so it's 32 in Fahrenheit. So it's giving me the actual number. That's a regression problem. And then, like I said, a classification problem is more like, is this a cat or a dog? Cat, dog, bird, something. Okay. So those are, obviously, we can do a lot more than machine learning, but in something like a machine learning foundations course, we usually stay to just those 2 things. You can do a lot with regression, actually. Okay. So yeah, so that's basically that. Real valued numbers is what that should say. And then finally, performance evaluation also depends on whether we're doing regression or classification. So for regression, we usually use something called the R-squared. It's a metric. And then for classification, we use accuracy, precision, recall, F-measure, and something called the confusion matrix. It's just stuff that you will start to see, and eventually it'll make a lot of sense. Okay? And there's equations involved. All right, so anyway, that's the machine learning pipeline. It's usually basically like everything that we'll cover in this semester. It's always building this, except that imagine we're taking out boxes and putting in other boxes, right? So where we have the ML algorithm, that circle, you take out K and N and you plug in naive Bayes. And you take out naive Bayes and you put in a neural network. Yeah, Henry.
Would you want us to like take the full word so just like plug in? Like,
you mean in the code?
I guess that's what I'm thinking.
In the code, no, you won't have time for building such an application. It's going to be more basic. Like you got the algorithm, all your time will be consumed in just the data. The data will take a lot of time, usually. Okay. All right, so that concludes the pipeline. Any questions on it? So again, all semester, we're doing this. Inputs come in through here, they go out that way, and then they get a value. But what you're learning about is we're adding more boxes, or this box can be replaced by this box, and so on. Okay? All right, so hopefully that makes sense. Now, the next thing is, okay, you want to go from a problem to this X and Y over here, which is kind of the format that I'm recommending you use so that once your data is in that format, it can just nicely go into your Weka or your Keras or your TensorFlow. It doesn't matter. You make it like X and Y, and it should fit in a lot of these frameworks, okay? So that's what we're going to discuss next. So and we have about a few minutes, so we'll do maybe one problem, okay? And just to kind of give you an idea, and then on Thursday, we'll pretty much spend the whole day just on that, okay? Got it? All right. So and also I may introduce Anaconda on Thursday. So please install it so that I can just show you at least a few steps of how to get it to work. Okay. Remember, you go online, download it, install Anaconda. All right, so let's go back now here. All right, so I have, as I said, 2 Word documents. What I do usually is I create a Word document and then I create another one that's the homework, and then next semester that's just examples, and I'll create new ones. So I'll create new problems for your homework assignment, so we can just grab any of these. All right, so I'll start probably with, let's start with this one. Should just be Word documents. Okay. All right, so basically, this is the format of how I do this, okay? So as you can see, I have 5 problems there. 1, 2, 3, 4, 5. And they should be different, hopefully. And so usually for all those problems, I want you to identify and or define the following. So it's going to be the X matrix, right? So it's literally a matrix. Or it's going to be the Y vector. You want to tell me what the samples are. You need to define the set of features. You need to define the dimensions of X and Y. And you need to indicate what they mean. That's usually, if you can answer those questions for any problem, you're on your way. Okay. And that's kind of the idea here. I'm trying to give you like this recipe almost of take a problem and how do you start to solve, and build your solution. Okay. So let's take, so let's see, I have a few examples here. Let me pick one. So I have an image classification model for the detection of Airbus A320 passenger jets while in flight. Okay, we have to make some assumptions here. But this is probably an image-based kind of thing. We're going to take a picture of an airplane in the air, and we just want to say if it's a Airbus A320 or if it's some other plane, a helicopter. Huh?
737 Max.
Or a 737 Max, exactly. One of those, right? So that's kind of, you can make those assumptions. That's okay. Another one is a model for predicting temperature and pressure inside an industrial iron melting oven, like the ones they have in Gary, right? So, okay. So how do we do something like that? That's a different problem, actually. Notice that I'm asking for you to predict 2 things, right? Temperature and pressure. It's different. They're all have a thing somewhere in there. Number 3, a model that translates text and speech from one language to another language. That's a very hard one. Yeah.
Use like the analog signal
For which one?
for the like text. I'm sorry, speech to text. Probably.
For the speech part, you're going to have a wave file. So that's a signal. So then you have to use those techniques of signal processing, like what you're saying, extract, whatever. I don't expect you guys to know these things, okay? Don't get too technical. At the end of the day, I just want you, the process is to go from a problem to X and Y. You get that, right? It's all we're doing. But if you know about that stuff, then oh, okay.
I'm scared right now.
Yeah, we'll do something simple, something very simple, okay? But obviously, the better you do that, right, the better your results. So if somebody's paying you $50,000 to develop this, you're like, oh, you know what, I'm gonna go read about this, whatever you say, right? So the better you make it, the better your model can be. Number 4, a classification model to detect types of cars in images. So this would be like you could think of it as trucks versus like sports cars, something like that. So that's an image one as well. And then a classification model to detect the type of music in an audio file. So this goes back to audio file. So it really doesn't matter which one we do. Let's do number 2. I think number 2 is kind of the more simpler one. So remind me what it is. So it's a model for predicting temperature and pressure inside an industrial iron melting oven. Okay, so I'm going to switch to the whiteboard here. I need to How do I get back to this? Oh, stop share maybe, yeah. Stop share. All right, and then whiteboard. Okay, there we go. All right, so we've got a problem, right? A word problem. Hmm. Yeah, sorry, my pen does not seem to. Okay, sorry, I'll have to do it on the board. I'll record these next time, so. Because I can do it with this, but I won't be able to write, well, I'll have to check what's wrong. All right, so then I guess, so we don't have dead air here. I'm just gonna stop it.